All right, this is another problem from our normal or central limit theorem. So this problem is taken from the Brace edition 9, and this problem says that we have a mutual fund that specializes in stocks from British Isles, continental Europe, and Scandinavia. And in this fund there are 100 stocks, and the random variable represents the monthly percentage return from this fund. So we want to know that based upon this fund that has a mean of 1.4% and a standard deviation of 0.08% or 0.8%, we want to know a few things about that. So the first question we're asked is the average monthly return on the Dean Whittier European Growth Fund approximately normally distributed? And the answer is yes, even though in the following questions you'll see that n is less than 30, and there's no indication that that's normally distributed. We can assume that it is normally distributed because there are 100 funds within the growth funds, and therefore we already are talking about an average for each of the random variables, and therefore this already evokes the central limit theorem and is therefore normally distributed. So I've written that here so that you can kind of see that already. Now part B says after 9 months, what's the probability that the average monthly percentage return will be between 1 and 2%? Now on this, the percentages are just the variable names, so we're not concerned with changing these to an actual percentage. So you shouldn't concern yourself with actually doing 0.01 or anything like that, because that's not what these actually represent. They do represent simply 1 and 2 because these represent 1.4 and 0.8. So we are looking to find a area under the curve here for being from 1% over here and over here to 2%. So we want to be on both sides of the mean. And that means that we are going to have to standardize, of course, so that we can see this. And so we have the probability that we have 1 minus the mean, which is 1.4, remember no changing to decimals, that's not necessary, divided by 0.8, and we're going to divide that by the square root of 9, because remember this is the central limit theorem being called upon, and the standard deviation is actually the standard error, which is the standard deviation of the population divided by the square root of n. I'm going to go down here for the second part of it as 2 minus 1.4 and divided by 0.8 divided by the square root of 9. And then we'll go ahead and we'll calculate those out, and we'll have our probability of P being between two values, or Z being between two values. And let's see, what are those values going to be? So we have 1 minus 1.4, and we have that divided by 0.8, and then that's multiplied by 3. And so that's a negative 1.5. So this is a negative 1.5 here. And then on the other side we have 2 minus 1.4, and then that's divided by 0.8, and then that's multiplied by 3, and that gives us 2.25. So now, because we have one positive z and one negative z, remember that when we go to a negative z table to look this up, this is going to look like 1 minus the probability that z is less than negative 1.5, and then because being greater than a 2.25, being in this tail over here, right, is the same as being in this tail over here, we're going to subtract the probability of being a z being less than a negative 2.25. So we have two values to look up, and then we can compute our probability. So going to our table, we have 1.15, So we have 1.1 and 1.15 right there. So 0.1251. So 1, 2, 5, 1. And then we're going to go to 2.25. So moving up to 2.2, and 2.25 is right there, 0.0122. So minus 0.0122, just like that. And now we can figure that out. So we have 1 minus 0.0122 minus 0.1251, and that is going to give us 0.86. So this is 0.86. Let's see, what was that? 0.8627. And that would be our final probability. Now I kind of ran out of room there, so I put it back up here, but I would normally put it right after that. So our next value is the probability of being between 1 and 2, but now our n is 18 months. So I'd like to ask you what you think will the probability look like. Will the probability get larger or smaller? So remember that we would have this probability here, the 1 minus 1.4 divided by 0.8, that's going to get bigger by a multiple of 3. So now I have 18 months, it's going to be getting bigger by a multiple of 4 or larger. So that's going to put these farther and farther out here, isn't it? And if I'm looking at the area between, that's going to put more and more area between those. So we're going to actually be ending up getting more area than we were before. So part D's answer, we're going to answer, we have already answered by thinking about that. So let's just show that and prove it. So we have 1 minus 1.4 divided by 0.8 divided by the square root of 18. And then that's less than my x bar minus the mean divided by sigma divided by the square root of n. And so we have 2 minus 1.4 divided by 0.8 over the square root of 18. And now I can't do that on my little simple calculator, so I'm going to have to go off of the computer here and actually do it on my calculator. So I'm going to calculate the left side, and I get negative 2.12. So this is a negative 2.12 less than a z less than a oops, let's see. I have to do that again because I just hit a wrong key. All right, so the right side looks like 3.18. And so you see those values are way farther out than the ones that we had here in part B, which ended up being at negative 1.5 and positive 2.25. Now we're at negative 2 point something and positive 3 point something, much further out there. We're getting a lot more of the distribution. So we're going to have 1 minus the probability of a z being less than a negative 2.12, and then minus the probability of a z being less than a negative 3.18. And remember that I'm doing the negatives because I'm looking at what's in the tail, right? Here's my distribution, and I'm over here and I'm over here, and this is my negative 2.12, and this is my 3.18, and my 3.18 the area beyond here and the area over here, if I subtract that from the entire distribution, that's how I end up with what's in the middle. And so this tail on the right, greater than 3.18, is the same as if I were on the left side and being less than that. So remember, that's where I am getting that again. So this is 1 minus, and I'll go back to my table here. So I have 2.12. So 2.1 and move it over here to 2, so 0.0170, and then minus, and now I'll have to go find my 3, so here's 3.1, and 3.18 is all the way over here, so 0.0007, and now I can find that difference. So 1 minus 0.0007, and then minus, and then 1070, 0.107, and that gives me 0.8923. So 0.892 and 3. And so comparatively to my last answer, we had the 0.8627. So now you see 8.9, I've got more area under the curve. Okay, now part E, we're going to be greater than 2% at 18 months. So the probability that my x bar minus my mu over my standard error is greater than 2 minus 1.4 divided by 0.8 divided by the square root of 18 again. And I think we already calculated this. Let's see. Didn't we calculate this before? Oh yeah, right here, right? So this is going to be negative 2.25. Oops, not negative 2.25, positive 2.25. So this is the probability that z is greater than 2.25. And that's the exact same probability that we had before. We knew that that was the probability that a z was less than a negative 2.25. And we had already found that probability to be, and we know it's fairly small, it was 0.0122. So 0.0122, that's our probability. And remember, the probability that we're looking up this time, right? Here's our mean at 1.4, and here's our 2 value out here, and this is the area that we're trying to find. And we know it's going to be fairly small because it's beyond 2 standard deviations out. And that's what it looks like, 1%, or 1.22% essentially. So now let's go back to our problem and see if we've cleaned up all of the questions here. Now, the next question in this says, would that shake your confidence that the population mean is 1.4%? Well, what this is really asking is this an unusual value? And remember the idea that unusual is anything outside of 2.5 standard deviations. So anything less than that 0.1% or less, anything less than 1% is usually the idea, because we have a 95%, right? Anything that's unusual starts out at 2 standard deviations, and it starts getting very unusual about 2.5 to 3 standard deviations. So this is 2.5 standard deviations out. I'd definitely begin questioning it 2.5 standard deviations out. Anything that's getting down there and only having a 1% chance of happening, that's not very often that it's happening. And it's been going on like this for 18 months. It's not a very likely occurrence, is it? And so the markets are probably increasing, and we may want to take that into account. All right, so that pretty much wraps this up. What I would like to do is I would like to go over the idea of how to find probability on a calculator. So I'm going to make a short little video on my using my calculator to show how to find these probabilities, and then I will be going on to the next topic.